This afternoon, we are looking into surd, and a surd is an irrational number, such as root 2, root 3, root 6, and etc. A surd, these are numbers that we don't get exactly the square root. So let's go further. We are looking at simplification of surd. Let's simplify root 24. We picked root 24. We'll try to look for the factor of root 24. But what will have to be in your mind is you have to look for a perfect square in 24. So we have 2 here. 2 here will give us 12. 2 here will give us 6. 2 here will give us 3. If you look at this number, we are not having any perfect square there. But if you look at 2, 2, these 2 will give back to what? 4, which make it to be perfect square. So for us to look for the factor of 24, we say 4 times root 6. And what is the square root of 4? 2. Do we have the square root of root 6? No. And the final answer will give us what? 2 root 6. As I've said earlier, in irrational number, we don't have exactly the square root. So a surd is an irrational number. You look for 24, the factor of 24. I try to look for the factor of it. You give us 2, 2, 2, 3. If you pair these two together, we give you 4. And 4 is a perfect square. What is the square root of 4? 2. Do you have the square root of 6? No. Let's pick another example. Example 2. Example 2 says, simplify root 54. We have root 54 here again. I will take the long division again. 54. 2 can go 2 here, 2, making it 14. In 14, 7. What can go again? 3. 3 here, 9. I can quickly see root 9 as a perfect square. I will now say 9 times root 6. We give me 54. What is square root of 9? That is 3. Did I still have square root of 6? No. That is 2. The answer is what? 3 root 6. Let's pick one example more. Root 3. You say root 32. So let's pick 32. I believe some people should know the factor of 32, which is straightforward. You can still take 32 here, 2 here, 16, and 16 is a perfect square, and that is root 16 times root 2. What is square root of 16? That gives us 4 root 2. And this is how to simplify. Let's really brush back again. Simplify root 24. You try to have the number, the factor of root 24. Some people can say 8 times 3, you know it immediately. But I said try to check in a long way. 2 here 12, 2 here 6, 2 here 3. And look for the one that has 2 pair. 2, 2 has 2 pair. What does 2, 2 give you? Give you 4. 2 times 3 give you 6. What is square root of 4? 2. And we have this. The another one too, we have 54. Try to get it immediately. 2 here 2. Remainder 1, 14, 2 here 7. And ask again, can 2 go there? No. 3. 3 here 9. Immediately you decided that 9 is a perfect square. Say 9 times what? 2 times 3 is 6. And that was the square root of 9, 3 root 6. I pick the example 3 again. Simplify 32. 32 give us what? 2 here is 16. 16 is a perfect square. Root 16 times root 2. What is root 16? 4 root 2. We are looking at addition and subtraction now. We have just done simplification. And looking at addition and subtraction, it says 2 similar surds can be added or subtract from each other if they are in their simplest form. What are we saying? The moment you want to add or subtract in surd, the 2 of them have to have the same surd. It's like a boy and a girl. You can't add a girl and a boy. It's either you add a boy and a boy, or a girl and a girl. Exactly the same thing to solve. If I'm talking about root 2 and you have root 2, this is the time you can add them together. You can never add root 2 and root 3. Let's take this example that we are having here. It says what? It said 3 root 2 minus root 18. Root 2 has been simplified, which is the simplest form. So, but root 18 has not been simplified. We quickly do that, and I believe you know what 18 can give us, which is what? 9 times 2. Or you quickly go for the way I told you initially, you say 2 here, 9. 9 is a perfect square, you say 9 times 2. And we have 3 root 2 minus, what is square root of 9? 3. What is square root of 2? Root 2. If you look very well now, are they not having the same root? They are having the same root. And 3 minus 3, root 2 is common to two of them. 3 minus 3 will give us what? 0. Root 2. And finally, the answer is what? 0. Are you with me? Let's take second example. The second example says 2 root 150 minus root 96. So 2 root 150 minus root 96. Use the pattern I've told you. Put 150, look for 152 here, 7. Yes. What can go here now? 5 can go. Let's pick 5 immediately. 5 here, 1. 5 remaining what? What will you give? That is remaining 2. That is 15. What can go again? 3. What can go there? 5. What can go here? 5 and 1. You can see that I did this separately. I just the way my mind came in. How many one that you see that has pair there? How many number that has 2? That is pair. 5 has 5 in 2 places. That is a perfect square. 5 times 5 will give us what? 25. Immediately you come here, you say 2 root 25 times 2 times 3 will give us what? Root 6 minus the same thing to root 96. You do that again. 2 here, 4 in 16 now. That is 8. 2 here again, 2, 4. 2 here again, 12. 2 here again, 6. And we have 6. You can see this is a pair, this is a pair. That is 4 times 4 give us 16. And that will give us root 16 times root 6. Let me write it very well. Root 16 times 6. And from there, what is square root of 25? 5. And root 6 is still 6. Root 16 is what? 4 root 6. 2 times 5 give us 10. Root 6 minus 4 root 6. Are they not having the same root? Yes, they are having the same root. That means you can add or subtract them. And what is the operation there? You say 10 minus 4 into bracket what? Root 6. 10 minus 4 give us what? 6 root 6. And that is our final answer. If you really want to understand this, you must know how to get the perfect square from the number. Just use the log division, the prime number there, and be asking yourself, and anytime any of the number has a pair, that makes it a perfect square.